Hello everyone, this is Samuel from Learn Programming Africa, and we are here today to solve the recursion problem as well as to see what recursion is and other things. Besides that, I am on Telegram. I have a channel which says Learn Programming Africa, and its username is just as you can see, Learn Programming Africa, with no space, with no underscore, and everything written like that. And I have Instagram, which is Learn Programming underscore Africa. You can go there and follow me. And also subscribe to this channel to get updated on job opportunities and other tasks we have planned in the future. This is also other thing, alx-africa students, which is to gather the students who have joined alx so far, and to give to make things actually you can ask question here, and there are a lot of group there, but you can come here and have a one-on-one, and as well we can also video chat and other things. Subscribe here and we will be good to go. As you have seen, I have a Facebook account as well, where we are posting an interview question from top companies like Google, Amazon, Microsoft, and other LinkedIn, Netflix, and other things, other companies, big companies. We are posting daily the challenges that are recently asked on, or the interview that are recently asked on these big companies. If you see them, you might be you might know where to look for example, for problems. To solve a problem on algorithm and data structure, you can go to HackerRank and Codility and other platforms. But we are preparing such platform for us, which is Learn Programming Africa, and it is coming soon, and we are going to build that project, and after that we are going to start building huge good projects on our channel as well. Thank you for watching so far, but still please subscribe here so that we can work on we can be motivated to go through this program the entire year together. That is my announcement. Besides that, let's get into the project. Today we are going to open everything together. That is a new trend, I think. So I haven't done the quizzes as well. Just let's start from what is recursion. So let's close the other things, close tabs to the right and close here. As you can see, recursion is a function that calls itself, and it is very useful for problems that are being broken down to simple or smaller problems. So there you can use loop all you want, but always choose the best. For example, there might be a best solution by recursion for that problem, but for example there are multiple trees. There is a tree data structure that you need you must know recursion to solve. We use recursion for tree data structure mostly. There is a data structure called linked list graph, and if you go and search data structures that are available. You can see there are a lot of data structures. So array is one of them, linked list, stack, queue, and more other things. So besides that, if you want to solve a tree based problems, you need recursion. So recursion is just you need it in, for example, there is a binary search and other things, but the actual thing is why I have told you why we need recursion. But what is recursion? Recursion is a self-calling function that needs must be for a problem that are needed to be broken down and solved in piece. And the other thing is it have to have a base case, which is the exit function. So C programming supports recursion. This is function that calls itself. For example, if this is recursion, this is calling itself inside itself. So this function is calling itself. So this is recursively calling itself. So this loop or this calling will be forever. There is no base case here and the like. So but while using recursion, programmers need to be carefully define an exit condition, which is to break out of the loop, or in some cases there are memory limits on our computer, so it won't be infinite loop, so we don't need to worry about that. Recursive functions are very useful to solve many mathematical problems, such as calculating factorial of numbers, generating Fibonacci series, and many more. So let's go into our projects and quizzes, and the quiz will show us, I think, pretty much everything. So I haven't done the quizzes. There is no checked mark here, if you see, as you can see. So let's go dive into it together, and if we got the question wrong, we are going to run it on code block and check the correct answer. And today's general requirement are the previous ones plus these ones. Don't forget to push your header file and not this one. You are not allowed to use any kind of loops. This is the basic requirement that they have given us, and I don't think we know this static variable, what the static variable is. I think we are going to look into it on Friday. So until then, let's keep this here. So let me check here something and let's go back. All right, let's start solving a recursion problem. So let me open text editor and minimize it, and I will try to explain everything here. So this function is what does this code print? So let's go down, and our entry point always is int main. So we are going to come here. Let me make this on top, always on top, so that if I click on other places it won't go away. So this is going to come here as an entry point. For C programming language is a main function, so it is going to come here and come down here and say print2. So print2 is called. So when print function is called with a variable or a parameter 2, this function is going to be called. As you can see, print receives an integer which is 2. We have given it here, so we have 2 there. On here we have 2. So when we print this digit, we are going to make do print f2. Then we are going to come back here and nb minus minus, which is going to make nb equals to 1. Then if nb greater than 2 if nb greater than 0, it is going to check if nb is greater than 0, and again it is going to call print function, which is this one, with dot nb. So 1 is greater than 0, and it is going to come back, and here nb is going to be 1. So it is going to print another 1 here. There is no new line, so it is going to be on the same line. So it is going to print that, and it is going to come here and nb minus minus, which will make this -1 and equals to 0, and it checks if 0 is greater than 0. It is not, so it is not going to call this function. So that is how it is. Let's check. I am going to choose 2 1 here, and let's check this code on a code block. So I'm going to create a new project, console application, and come here, console application, C, next, recursion, and finish. So I'm going to go to the main function and come here and paste here. As you can see, this is it. And if I compile and run this function, it is 2 1, as you can see. So this is going to be 2 1. So let's go down. As you can see, there is a main function. That is why I have removed the first main function. So it has called printf, and it is making it minus minus here. So that is what happened there. So let's go back here and go to the first question. What does this code print? This code is going to this code is printing a void print. So we are going to go to the entry point. So let's go to here, and int main is our entry point. We have 4 first. Let me come here and write that. We are calling print with 4 here, and I'm going to write 4, and what this is our variable var, and this is our print. So here it comes down here, and int nb, then nb is going to be 4, as you can see, and it is going to print first. The first to be printed is nb with no operation first, so it is going to be 4, and it is going to make minus minus 4, which is the same as nb minus minus. So it is going to make this -1 equals to 3, and with 3 it is going to check if nb equals to if nb greater than 0. It is 3 is greater than 0. This statement is true, so it is going to call print nb with 3. So this is now it is going to be called for the second time with print 3, and so cut here and paste here. For the second time, print is going to be called with integer 3. Then after that, print f is going to print and the number that was passed to it, which is 3. So after that, this is going to minimize it by 1, which is 2. then it checks and again come here and it is going to call a print by with 2, and it is going to print 2 here, then it is going to minimize it by 1 and it is going to make it 1, and here it is going to come and print 1 here, and then after that it is going to print 1 first here, and -1 which is equals to 0, and if it is 0 it is now going to be the same greater than 0, so this is going to be what is printed, which is this one. Let's check this code as well by going to code block, and here I'm going to minimize this one and I'm going to replace the entire thing here and build and run. As you can see, 4 3 2 1 is the answer, so code block has sent us what the answer is. So let's get back here and go to the question number 3. Okay, question number 2, which is this one, and what does the code print? So this what does this code print? So let's come here and so let's do this. Let's do this. This is going to be function calls. This is going to be variable change, and this is going to be printing values. So we have separated this into three things. So let's go here and come down to our entry point, which is main. So after this one it is going to call print 4 here for the first time, so it is going to be 4. So after that print is going to be printed with 4 here. It is going to be print 4 as nb is 4, and the variable nb equals to 4 is now +1, and nb become 5. So it has changed. Then it is going to check if nb is less than 10, 5 is less than 10, so it is going to print nb. It is going to call print nb with 5, so it is going to call here print 5 here. So as you can see, print 5 is there, and when print 5 is being called, it is going to print that number 5, and it is going to change this to with 1, and it is going to add 1 here, and nb is going to be 6, and it is going to check 6 is less than 10. Yes, so it is going to call print with 6 here. Then it is going to print 6, and this continues up to n is equals to 9. If n is going to be 10, it is now going to call this one. So on 9 it is going to be it is going to end on 9, but it is going to print this whole thing as I have just showed you. So we are going to choose this one, and let's check our code on code block. Come here, and after you come here, paste it here, and let's see. As you can see, 4 5 6 7 8 and 9 is what it has printed out. So let's go down. What does this code print? So let's come back, and let me try explaining the basic, and then we are going to finish it like this one. So I'm going to come back here, nb int main void print 4. So it is going to start with print 4, then print 4 is being called. So after that, it is going to check if 4 is less than 0. It is not, so it is going to go down here and print number 4. Then it is going to change the variable nb equals to 4 minus 1 and equals to 3, and it is going to call print with 3, print 3. Then it is going to check if nb is less than 0, and if it is not, and it is going to print 3 and 2 and 1, and we are now minus 1 equals to 2 minus 1 equals to 1 here, and here as well print 2 and print 1 here as well. So we have print 1 here, and we have printed up to 1, and on 1 we are going to come here, and 1 is 1 less than 0. It is not, so it is going to print 1, and after that it is going to minimize this by 1 and equal to 0, and it is going to call print by with 0, and on 0 it is going to say if nb is less than 0. If nb is less than 0, 0 is not less than 0, so this statement is false. It is going to print 0, which is 0 here, and it is going to make change here by minus 1, which is minus 1, and it is going to call print nb with minus 1, and it is going to say, it is going to check if minus 1 is less than 0. This is true, so it is going to return. So it is going to exit out of this code, and we don't have to print anything after this one, and the answer to this is going to be this one. And if you want us to check this on a code block, it is going to be like this, and I'm going to come here and paste it here, and let me close this one and build and run. As you can see, 43210 is the result, so we are still correct. So let's come here and finalize this by this one, and I'm going to come back here and remove this one as well, and come here as well and remove this one. So what does this code print? And let's see what it is going to print. So int print this one. So I'm going to come back here, and I'm going to make our entry point, which is print 4, and there is a variable change, there is a printing value. So let's see what we are going to do. So if nb equals to 0, less than or equals to 0, return 0. So 4 is not less than or equal less than 0, so print digit nb plus print nb minus 1. So here here what it is doing is as you can see. So let's come back here, and okay, so now we have print 4, and it is now going to finish this line until it is going to be it is coming back here. So all right, what does this code print. We are going to see what this code print, and if they asked us what it is going to return, we are also going to give them. So let's come back here and do what we are going to do. So here, as you can see, it is going to be nb is 4 plus print nb minus nb minus 1, which is 3. So n4 minus 1. The first step is here, and as you can see, this is a function call. It is not going down, rather than it is going to be, it is going up. And as you can see, 4 and print 3 here, and it is going to call this with 3, print 3. So we are in this function, which is calling this one, and this is going to say 3 plus print 2. As you can see, nb plus print nb minus 1 is going to be this is being called. So it is the action is going to be, let me make it curly brace, and this one. So we are in this thing now, and it is calling again a function, this function. So I'm going to make this as well a curly brace again, and in the curly brace I'm going to say 2 plus print 1, which is nb plus print nb minus 1. So until I get a result, I'm not going to stop. So plus so I'm going to open a curly brace again, and print 1 is going to be replaced with 1 plus print 0. So this is also going to be replaced by 0 plus plus print minus 1. I think you have understood this. 4 is print 4 is replaced by this entire statement. Print 3 is replaced by this entire statement. Print 2 is replaced by this entire statement, and print 0 is replaced by this one. So let me if we call print with minus 1, and what will happen is going to be 0 is going to be returned from this function. So we are going to replace each and everything with by going back. So I'm going to go back one step at a time. So here print 0, print minus 1 is going to be, the value is known, so it is going to be minus 1. So this is going to be deleted, and it is going to be replaced with 0, as you can see here. And we have 0 plus 0 here, so it is going to be 0, as we know. And print 0 is equals to this curly brace, so we are going to replace print 0 with this curly brace, which is 0, as you can see. And let's calculate this one. Print 0 1 plus 0 is 1, and print 1 is in this curly brace. It is going to replace with this curly brace, so I'm going to remove print 1 and the curly brace around this thing. And we have 2 here and plus 1, so I'm going to say 3 here, and print 2 is going to be replaced with these 3. So I'm going to remove this as well, and this can be done, so I'm going to make it 6. 3 plus 3 is 6, so this print 3 is going to be replaced with this one. So as you can see, the answer to our printing thing is 4 plus 6, which is 10. So all right. Oh. So I have forgotten something, which is what exactly? Yes, I have forgotten something, so let's run this on our code block, and we will be explaining this in detail. I think I have forgotten some things, which is where the function is going. So I'm going to come here and I'm going to put a breakpoint here, and I'm going to build and run. It is going to be 00246. The answer is going to be 00246, and why that is happening is let's see why it is happening. So all right. Okay, as you can see here, I have done this. So let me come here. First, print 4. I'm going to replace everything with a curly. I'm going to come here actually, as it is giving me multiple as it is going to be giving me some options. So I'm going to say print 4 is going to be this one. I'm going to do this one actually. So it is going to be 4 plus print 3, and this is going to be 3 plus print 2, and it is going to be, this one is going to be like this, print 2 plus print print 1, and this is going to be print 1 plus print 0, and it is going to be again, this is going to be print 0 plus print 0. So on here we are going to do something. So this is also calling the entire function here, which is print function is being called by 0. If it is going to be called by 0, print 0 is, if it is going to be called with print minus 1 actually, minus 1 here, if it is going to be called with minus 1, it is not going to pass this one, and it is going to return 0 and do nothing. So as you can see here, this is going to be 0 and nothing is going to be done. So on print 0, this is going to be 0, and print 0 is 0, and as you can see here, let's see, okay, 0 is not less than 0, so it has passed this condition. So it is now going to, it is going to run this function first, print f digit 0 plus print -1 or something. So it is going to be quit here. So here, as you can see, 1 plus print 0 is going to be 0 here, as you can see. So print 0 is going to be 0. It is going to print 0 first, so our print is going to be 0, and nb minus minus is going to be -1, and return nb is going to be -1. So it is going to return -1, but it is going to print 0 first. Then 0 is printed here for the 0 first, for print 0, and it is going to be replaced by 0 here. So with 0, so as you can see, it is printed 0, and it has returned 0. It has returned -1 actually. So here it is going to be -1, as you can see. So it is going to say 1 plus -1 is going to be 0, and print 1 is going to be, print 1 is gonna come from where? Print 1 is going to say as well, it has 1 is not less than 0, so it is going to print nb plus whatever returned from this one. So I'm going to, it is going to say print nb plus 1 minus 1, 1 plus -1, which is 0 again. It is going to print 0 here as well. And what does this return? What does nb of or nb1 is going to return is, it has nb equals to 1, which is 1, so nb is minus minus is going to be 0, and what it is going to return is 0. So here as you can see, it is going to be replaced with 0. So here as well, it is going to be replaced by 0, and 2 plus 0 is going to be 2, and we are at print 2 here. So print 2 is going to say 2 plus whatever returned from the previous one, which is 2. 2 has 2 is going to be printed first, and 2 is going to return 2 nb minus minus, and nb minus minus is equals to 1, and 1 is going to be returned. So from here this is going to return 1 for us, and print 3 is going to be 3 plus 1, which is 4. So here 4, and print 3 has also execute these 3 things. So I'm going to print 4 first. 4 is printed, and the return type, the return value is going to be nb minus minus, which is 3, and return nb is going to be 3. So as you can see, yeah, here NB was 3, it is now 4. As here it was 3 plus 1 was what we had, so NB was 3 here, so NB is 3 here, so NB minus minus is going to be 2, so return NB is going to be 2, so this is going to be replaced by 2 here, and so this is going to be 6, but 4 plus 6, as NB is going to be 4 here, so this is going to be 6, and 4 is also greater than 0, and it has a right to execute these things, so it is going to execute print 6 first, and NB minus minus, NB minus minus is going to be, NB is going to be 4, so NB minus minus is going to be 3, and what it is going to return is 3 here, so this is going to be replaced by 3, so this is our return value. Return value is 4, and printed value is 00246. So as you can see, I think somehow recursion is clear, but we are going to look into recursion quite a lot in this project, in the following project, so don't worry about recursion, and you can also read on recursion by using other platforms or other challenge giving platforms like HackerRank, as I told you. So let's submit this answer and check if it is correct. So everything is correct, and we have passed this part. So one of the questions that Google or Microsoft can ask people on their interview question is, please explain recursion to a 6-year old child. So you have to know what recursion is to explain that. So please explain that. I can explain it if you ask me about to explain recursion to a 6-year child. So I'm gonna say this. So the first one is me and that 6-year child is going to be stand on a line which has a lot of queue to buy or to buy something from a supermarket. So there is a queue, we are on that queue, and we want to know the number we are on. So how do we do that? So we are going to ask the person in front of us, what number, what line are you on? So it is going to say he don't know. He is going to ask the person in front, what is your number? It is not going to know, so it is going to ask the first one, and this continues up to the first person standing, and he is going to say, I am on number 1, and then the next person says, I am on number 2, and we know by that process. So this is actually one of the interview questions can be thrown at you from a big company, big tech companies like Microsoft. This was asked. They asked my friend, which is now at Microsoft, currently Microsoft US. So that is how I know. So let's continue to our task. The first task is write a function that prints a string followed by a new line. So this is put recursion. So we are not allowed to use a for loop or any kind of loop, so we need to write a recursive function. So here it comes. So let's me open this up and come back here, actually here, and alx low level programming, and I'm going to come back here and I'm going to do this one first. I'm going to add this directory, make directory this one. No, I'm not at cd desktop alx-africa alx low level programming clear. We are going to cascade our creation for now, so I'm going to say make directory 0x08 recursion and cd into this directory, and in here I need to do a couple of touches. So 0x0 dash puts underscore recursion touch this file main.h file underscore put char.c file and readme.md file. These are what I need here. So these are 1 2 3 4 files that are important for my code to run. So I'm going to clear out of this and ls. These are the files, and I'm going to come back here. Here is my directory, and I'm going to open the 4 of them at once. So I'm going to maximize this one, and I'm going to remove one without saving. So here the first thing is I'm going to add, this is recursion problem solutions. So I'm going to save this, and that is what is needed. So put char is going to be come from here. So I'm going to copy this one and paste it here and save it, and you are gonna go away, put char.c. So I'm going to say come here and do some if not defined the name of this header file main.h. What you can do is define it for me with this name main_h and if here, and I'm going to say int put char from here, copy the first defined prototype function prototype I need is put char here. So I'm going to put that there, and what is the next prototype? This is the next prototype. I'm going to put it here first here. So as you can see, it is there. So I'm going to go back here, and I'm going to include main.h, and I'm going to explain my function as this one, and I'm going to do this one, and I'm going to explain it here. Let me copy this, copy paste. This is a function to print pull a string recursively. I don't know if I have made it correctly. So anyhow, it doesn't matter. S is string parameter. Actually it is a pointer, so this is not going to return anything, so I'm not going to add any other thing there. So I'm going to say I'm going to say this one here, if this thing s dereferencing s is equals to null there. So as we know, this is an array of character, and we can use a pointer. The first, as you can see, s is referencing the first memory of the first memory of this string. So the first memory is going to be dereferenced when we use this pointer. So if that pointer is going to be, if that value is going to be null, what I'm going to do is I'm going to do this one, this thing, which is underscore put char new line. As it is instructed, our code should be done or done by the line. So that is what I'm going to write, and as this is a base case, I'm going to return. So for this recursion function, this is going to be the base case. So the recursive case is going to be calling this function, but retrieving through the character. For example, if some s is going to be equals to learn programming Africa, which is LPA, at the end it is going to have this one there. This is how it is. So this is by default there, but I am adding it for the sake of explaining to you. So this is going to be, this is the first thing this is going to do is s, it is going to come to s, and it is going to see if the first element is the first element. In a sense, we are dereferencing using a pointer. So as an s is a pointer or an array of a character, it is referencing the first element address. So if we dereference that, this is going to say L is equals to this one, no, so it is going to pass. Then the last thing is going to be this one, so it is going to do this one is going to be equal to this one, and it is going to print out a new line and return. That is our end or our base case. So the other thing is going to be what, so if we have to put, or we have to iterate through it and print it. So if this is L is not equals to this, so what I'm going to do is print that character, put char dereference s, which is in our case L first, and what is going to happen is going to be s plus plus, as we have done on pointer, to reference the address of the next element on the string or an array. So it is going to be referencing to the p now, as we have added here. So the next one is going to be self call this function recursion with what, with s, as this one. So this is doing, this is moving the this code is moving this actually this the reference from this to this one, and this is going to call the function by s, which is s is now or the reference is now on here, so it is going to call it with the exact value, but the reference has been changed to this one. So it is going to come here and check if p is going to be equals to none. It is not, so it is going to put char p is going to be printed out, and s++ is going to add a reference or change the reference to this one, and it is going to call this function with the whole lpa /0, and it is going to the reference is going to be on a, and is a equals to null reference? No, so it is going to print a, and it is going to increase the reference to 0, and when it is going to put this and reference is 0, it is going to come here and it is going to return. So that is what is going to happen, and I hope this is right. And let's git add it and git commit. I haven't saved this, and git commit message the first recursion solved. Git push. It is going to push it, and let's check our code by coming here. What happened? All right, it has pushed it, so let's see what it is going to do. Right, so what is wrong? Let's see. Compilation error, which is I have forgotten something. So this is what I forgot. I'm going to remove it from there. This one is what I forgot, and save it. And so as you can see, it just told me this there is expected, it is expecting a semicolon before after this one. There is a definition for s, so I just need, if I just add a semicolon there, it is going to work, but that is also an addition that I have introduced. So let's continue. Git add all. How I saved it? Yes. Git commit. Let's beta check. Beta error. So git commit hotfix, git push, and it should now pass all the tests. So I think it is congratulations, so I don't need to check everything. So as you can see, there is everything is here, as you can see, is passed. So let's get going. So write a function that prints a string in reverse, which is with this prototype. So I'm going to copy this one, but on doing that, I'm going to come here and do this, and I'm going to remove puts char, remove 0 puts recursion, and save this one, and I'm going to come back here and clear. So I'm going to come back here, and I'm going to add this file touch what one dash print rev recursion.c clear. So I'm going to open this one. I'm going to include main.h, this one, so here I'm going to do this one, print recursion. So this is printing string in reverse using recursion. So this is going to take as string s, and that's all. So let's write again. So I'm going to say so the first thing is going to be, let's print our base case, which is if s equals to null reference, what is going to happen? I'm going to return. So here, if it is going to be null reference, it is going to be returned. So the next one is going to be s is going to be added on, and I'm going to call this function print rev recursion v, and I'm going to say this one is, and I'm going to do something here as well. I'm going to s minus minus here. I'm going to explain this after I wrote this one, put char dereferences. So this is going to happen like that. So as you can see, this is our base case. So we are not printing anything first, as you can see. So let me explain this by s equals to what, lpa again, and this one should be added on. So this is going to be simple. So I'm going to do this. So I'm going to open this as well and come back here. Okay. I hope it is going to be visible when I do this. So I'm going to come back here and do what I did previously. So this is going to be called with s, this one. So print var, this is print var is going to be called with lpa, this one 0. So it has called with this one. So the reference, which is l, the first reference, is not null, so it is going to increase it. The s is going to be increased to p, and it is going to call print ref again. So print ref is, so the s is referring to address of L first. So s plus plus is going to say, s plus plus is going to change this to point to p, and we are calling this again the same as this one. So I'm going to copy this v, and it is now going down, and it is going to be come up here, and it is going to say this one, pr is this one, and s is addressing this one. P equals to 0, no, so it is going to pass, and it is going to update s to what, s where to a, to address of a, and it is going to call again pr with the same exact number, but s referring to that one. So is a equals to 0, so it is not, so s is going to be addressing now the null reference, so it is moved back. So here it is going to say again call this one, and is s 0, yes, so if s is going to be 0, it is going to return. So this has returned from the function. So the returned part is going to be, after returning, what is going to happen is going to what it is going to do is it is going to do this one first. So this is returned back, so this is done for. So s is back here, so it has returned. So this function is going to say this we are on here, so s minus minus is going to make this from move this back to this one, and after this one it is going to put char this function. So after this function there is nothing to execute, so it is going to end or execute get out of the function. So for that reason it is going to move back here. So after printing a, it is going to print f. So this is done here as s minus minus is moving back this one, so this is going to be moved back, and here this is put char is going to be executed, and a is going to be executed. So after that, after a is executed, it is going to do, let me connect my Wi-Fi. Okay, after it prints a, it is going to look back here, and the function is done. So it has after this is done, this is going to get back here, and it is going to s minus minus is going to update the reference to point to, and after that it is going to print p here, put char is going to be p is going to be printed. Then it is going to say it is done. So in between this is what happened here. So in between this, so it is going to complete this function, and it is going to s is going to make l to make l to point to l, and it is going to done this one, and it is going to put char L here, and after it has completed this one, this is going to be done, and that is how it is going to print out APL when we give it LPA. So this is that, and let's check our code. First Betty one trailing white space where on line 10. Line 10 is here. I don't need actually this entire line. Save, and if I bit check on it, it is going to be that one. Clear git add all, git commit message, and it is going to recursion for reversion. So git push, it is going to be pushed, and I'm going to start my server, and it should pass everything without giving me any error. Yes, it has passed. So and there is that. And the next question is going to be on this one. Yes, it is saying write a function that returns the length of a string. Prototype is this one, so it is going to give us a string length without using any loops. So we are going to come here and make this one and close this, come back here and this one, copy, touch this one, clear, and git. Let me open the file, this one, and I'm going to say copy this one, and I'm going to include main.h, and this is going to be this one. So this one is copied, this one is come here and function to this string param and return length of string. So here as well, what we are going to do is we are going to check or build our base case, which is referencing s equals to null character. This is a null character for us, and if so, what we are going to do is return 0. Return 0. As you can see, if this is a null character, the length is going to be 0. Otherwise s plus plus, and return here what 1 plus underscore Stirling recursion here, Stirling recursion s, which is this one. So I'm going to embrace it with this one. This is our recursive case, as you can see. So this is saying s plus plus is applied. So s plus plus, for s plus plus it is giving 1, so 1 plus that character. So if I explain this, it is going to take a long time, so I think it is going to call this one, then it is going to 1 plus again, and at the end it is going to return 0, then 0 plus 1 plus 1 plus 1, and extra up to that length. So that is how this is going to be done. So I think this is the recursive function we are going to use. So I'm going to git add all here, git commit message Stirling recursion done, git push, and this is a simple. So you can actually call a recursion function by for example, if I do this one, s equals to lpa again 0 here. For example, if L is, the first one is L, so L is not equals to 0, so L plus plus. So for L, 1 is added, 1 plus, then this is added, changed to P, and it is going to say Stirling with this whole we given, but referencing to P. So what it is going to do is it is going to call with P, and is P equals to 0? No, so it is going to do again 1 plus referencing to A. The first one is 1 plus Stirling A is going to happen. So after this it is going to return 0 on null reference, and when it returns 0, we are going to say 0 plus 1 plus 1 plus 1 is what is going to happen. So it is going to return as 3 at the end. That is what is going to happen. So let's do this and git add git commit hold, actually saving main file was forgotten. If I actually go to check my code, I have pushed once, but it is going to be an error. The error is going to give us a clue to what happened. So let's see. We are calling an existential, so it has passed. I think we have touched main.h as well by without knowing it. So let's go down and do the factorial. Here is a factorial, so I'm going to come here and add it here, factorial s, and I'm going to come back here and do this one. Actually touch 3 dash factorial.c clear. I'm going to open that factorial. I'm going to include main.h. I'm going to include main.h, and description is going to be here factorial is the function, so function factorial, and it is going to take what? Let me see. As it is going to take an n. N is number, and it is going to return an integer. So this is int factorial, so integer factorial. So it is, what is our base case is going to be, we have two base cases. The first one is if we are given a number less than 0. This is if n less than 0, what are you going to do? Return what? Something, I don't know. I think it is going to be given. This is going to be given. Let's check, but I can do by just saying return. This is going to do it. Let's say if n less than or equals to 1, less than or equals to 1, which is including 0. It is if 0's factorial is equals to 1 factorial and 0 factorial are equal, which are return 1, which is our base case, but this can be anything. If given, let's see, is it given? If n is lower than 0, the function should return -1. So it cannot you can skip it like I did, or you can come and respect the rule and -1, insert -1 here. So the other thing is else. So if this is passed, what we are going to do is return what? N times what? Factorial n-1. This is what is going to happen. So I'm going to come here. I think I'm going to beta check on this one, as I 3 factorial, yes. So space required between this one, yes, I have the parentheses are required on return statement. So I have forgotten here, yes, and trailing white space on line 50. So this should also be removed. So these are what I think. So if we give it 4, for example, it is going to say pass this 2 as this is not true, and it is going to say 4 times factorial of 3. Factorial of 3 is going to call this one factorial of 3. 3 is not this one, so 4 times, then 3 times factorial of 2, and it is going to be like that. And that is how you can do factorial. Git add all, git commit factorial is done. Git push, and let me check quick this one. I don't think something happened, so let me finish this one and come back to it. So I'm going to come here, clear, and I'm going to check my code, and let's continue to I think it's going to be done here. Yes, as I was sure it is going to do. So let's create this file first, copy, touch this one, and let's come back here and take this one, copy, write everything that returns the value of x raised to the power of y, prototype this one. If y is lower than 0, the function should return this one. So this is using recursion. So I'm going to open this one, come here, save, and close this one. I'm going to include so as you can see, I'm going to underscore power recursion, which is power using recursion, and this is x x power of y, and here y is the power number, and what is going to be returned? Return power power result. So this is going to be by this is going to be a power, a function. So let's identify our base case, which is if y is equals to 0 and y is less than 0. So if y is less than 0, as they said, I'm going to return -1. It is saying on the instruction. If y is equals to 0, which is our real base case, I'm going to return what? 1. But 0 raised to 0 is undefined, but we don't need to exclude that. But for now, if any number raised to 0 or power of 0, it is going to be 1. So otherwise, return what? I'm going to return what? X times underscore power recursion what? X comma y minus 1. This is a mathematics, as you can see. It is going to multiply x by x y times. So the first one is y, so the second one y minus 1, and up to y is going to be equals to 0, which is going to return us 1. It is going down that way. So if we say 2 raised to 3, if y is 3 and 2 x is 2, it is going to say 2 times power recursion 2, which is y is going to be 2. So still it is going to go back, and let me explain this. Okay, if we need 2 raised to 3, and on the first run it is going to say 2 times power 2 comma 2. So this is going to be 2 times p 2 comma 1, and this is going to be 2 times p 2 comma 0. So here 2 comma 0, y is going to be 0, and this is going to be 1, so it is going to be 2. This is going to be 2, this is going to be replaced by 2, so this is going to be replaced by 4, and this is going to be 8, as you can see. So I think I have made it quick, but that will do. So remember to read about recursion deeply, so that you can understand to explain to a 6-year child, so that you can recursion. So let's git add here, git commit power function in recursion, and push, and let's check our code here. Let's check it, and we are going down to a what? I think this is a compilation error. I have done something or forgot something, so let's do this. Okay, I'm not going to run anything, so return 1. So there is a compilation error in my code. So what happened? This is right, this is also right. X times power, I think this is a misspelling, so this one is a misspelling, so I'm going to do this. I'm going to come back here, git add git commit message hotfix git push, and then I'm going to check my code here. It should pass now. Yeah. Oh, what happened? Yes. I think it is with my problem. The problem is the connection. It is a connection problem. So but until then, let's read this one. Write a function that returns a natural square root of a number, which is this one, a square root function. Prototype is int square root recursion n. So as you can see, this is a tricky question. So let's go down and open this one, copy, touch 5 square root, and I'm going to copy this one, so here it is tricky. Include main.h, this one a square root, a recursion, copy v, here this is square root using recursion. It is simple if we are allowed to use a loop, but it is not simple anymore as we are not allowed. So this is a parameter to be a square rooted. So this is return is going to be return square root of a number. So here I'm going to do something. So I think there are two ways to do this. The first one is by adding a prototype here for additional function that I'm going to write, int underscore square root, which is underscore square root is not a function in C, so int integer, it is going to take int, which is 2 integers. The first one is a number, and then the second one is iteration. So that is that. So I'm going to return from here. I'm going to call the square root function and n comma 1 as this. So the first one is 1. So is 1, it is going to check is 1 a square root of n. If so, return it, otherwise don't. So I'm going to write the function that I'm going to find a square root with. So I'm going to say int underscore square root int n comma int I, and I can just do that. So here what I'm going to write is I'm going to square root recursive square root recursive square root. So that n is going to be a number, and iterator. So, and this is going to return a number. So here I'm going to say the first one is going to be integer, which is a square equals to I multiplied by I, which is I, which is the square of this number is the square of this number is should be equals to n. So I'm going to say this one. So I'm going to come back and read. If n does not have natural square root, the function should return this one. So it is not if a square is greater than n, what is it saying? Return -1. And if square equals to n, return that number, which is the square root of that number. So I is going to be that number, and else what is going to happen is return what? Underscore square root and n comma I plus 1, which is, as you can see loud and clear, a recursive function for a square root. So I plus 1 is going to be 2. For example, for 9 it is going to check for 1 first, and 1 times 1 is 1, and 1 is not greater than 0 and not equals to 0. So it is going to say n 9 comma 2, and for 2 it is going to check 2 times 2 is going to be 4, and 4 is not greater than 9 and 4 is not equals to 9. So it is going to continue, and it is going to say it is square root of 9 comma 3, and 9 square is going to be 3 times 3, which is 9, and it is not equals greater than n, and it is equals to 9, so it is going to return 3. So here we are going to get 3. That is how it is. So I'm going to git add this, git commit square root function using recursion, git push, and let's come back here, and there is something wrong here. Let's do this. Okay, let it run, and let me check my square root here. Oh, recursion can take that long, really? If something is wrong, it is going to take that long. So let's go down. I think my connection is a problem, but let's see. So yes, it is done here. What about this one? This is done also. So both are perfect. So let's go down here. Write a function that returns 1 if the input integer is prime number, otherwise return 0. So let's prime number is defined as a number that is divisible by itself and 1 only. So that is what happens. So returns 1 if the input integer is prime, otherwise 0. So copy. So let's come back here and come back here and v here, save it here, and I'm going to write this touch 6 dash is prime number dot c. So I'm going to open it. I'm going to include include main.h, and I'm going to add a description for my function. So I'm going to come here. I think I'm tired a little. That is why I couldn't write correctly. So prime identifier. So I'm going to close this one and this one, and they are not of use for me. So I'm going to again write one function for this one. So it is going to be easy, and as for the previous one, it is going to be written as a prototype here first. So I'm going to int and check underscore prime, and which is taking integer, 2 integers, and that's this one, and this is going to say return check prime and n comma 1 as well for this as well. So I'm going to write a description for my check function. This is going to return what? A one or 0. Let's remove this one, or 0, and it is going to take I, and I is going to be iterator, and n is equals to what? Number, and the function itself is check prime, which is what I'm going to write, and it checks prime numbers. So I'm going to write int check prime int n comma int I, if n is less than or equals to 1, what is going to happen is return what? Return 0. It to be in otherwise. So if, okay, let me go back here. So we are writing a prime checker function, so I'm going to say n factorial I is equals to 0, and I is greater than 1. What is going to happen is return 0. It is not going to be a prime number. So that is that. So the other thing is we are going to check is if if n divided by I divided by I is less than I, which is a prime number, print 1. This is it. So the recursion part is going to be return what? Check prime n I plus 1. So this is checking whether a number is a prime or not. So example, this is saying if, for example, n is equals to 13 and I is equals to 5, which is 13 divided by 5 is going to be 2, and 2 is less than 5, so that is what it is saying. So if, for example, 14 is divided by 5, it is going to be 3, and there is a remainder. So that is not going to pass this condition. So for that reason, we are going to pass this one, save, and clear git add all, git commit message what, git commit is prime function. Git push, and I'm going to do check is prime number. So I have taken more than 2 hours, so I'm going to do the advanced task on my GitHub repository, and you there. I'm going to attach it on the comment or under the description below if you need for this specific text only. So I'm going to check my code for an error. If there's something, I have prime and I comma I plus 1 print here return. Wow, I'm really tired actually. Git add all, git commit hot, git push. Lastly, I'm going to create a Git tutorial for ALX only. I'm going to actually connect another GitHub repository to an actual intranet, and you will see it, and that is another announcement. So I'm going to check my code. It shouldn't break. I think I'm good with C now. I think my hands have learned how to write C. So I think there is a Betty code style. So there are something that needs to be addressed. Betty will tell us what we need to address there. 6 is prime, and the first one is space required after this one on line 26. On line 26, where is line 26? So space before this one. So the other is no description for parameter member n, where on line 7. Oh, here. All right. Add n is number, add return what, integer, git add git commit what is prime, git push. So if I beta check on it again, yeah, it is done. So let me check my code and complete this tutorial for now. And that is all. This is done. I'm going to add an advanced task here, and we'll be in touch soon. Have a good day, and see you on the next one. And please subscribe. That is a last request, and I'm tired. Have a good day. Bye.